This is Lee McWhorter, cybersecurity instructor at Wazoo. Today we start do the workshop, first part of the new system administration class that began this week. Um, as I've already said in the previous videos, these are always meant to sort of supplement and complement the online material in the learning management system. This system administration course is a overview for our cybersecurity folks. We could teach a whole program on system administration, so this one course won't make you an expert system administrator, but it will give you an overview, and that's what it's about, because many times, of course, in cybersecurity, we end up having to work with, if we're on the cybersecurity team, the security team, then we have to work with the regular admin and system admins and things like that to make sure that things are working. We need to understand the breadth and depth of what they do so that we can understand how to interact with them and work with them and all the different devices and areas of the network and systems out there that we have to work with. So this class is geared toward that purpose. It's not to make you an expert system administrator to necessarily be able to work with every piece of equipment out there. I know many folks, including the current student, have some experience, and so this is, kind of meant to, like I said, just supplement and support and fill out your understanding of system administration so we can go forward and be successful in this cybersecurity program. Given this is a 2-week course or a 2-week model for this course, we'll be covering the first 5 lessons today pretty quickly, and then next week we'll get into the remaining 5 lessons. And our first lesson is pretty straightforward. It's an introduction to system administration, and it talks about, of course, what system administrators do. When you get down to it, a big part of what a system administrator has to do is install and maintain the various systems, and that can be networking, servers, obviously even some of the security equipment may be in their purview to manage and to maintain on a regular basis, firewalls, routers, things like this. And then, of course, they're also part of the team to secure and defend. Obviously, they need to understand security. They need to follow the security guidelines and procedures that will be dictated by the security policy of the company and the security team and organization. And so they're going to implement these things in. And obviously, in the broadest sense, actually, I really like to tell people that everybody should be part of the security team in the broadest sense. We need to train our users so that their users are educated so they don't fall for those phishing attacks and cause those kinds of weaknesses. They know not to, what to look for to avoid, possible, infections and things like that. Obviously, the system administrators and IT people need to understand security at a level so that they know the ramifications of actions they do and be aware of, making sure and testing things and reporting things. If they're going to have to do updates, then we're probably going to have to come back and rescan things and check things on the security side to make sure. But we work together, and of course, in many small organizations, somebody who is the security person may also be a system administrator, but we're talking larger organizations here where there is a dedicated security team and a system administration or IT team, then we work together. There is some review of some keywords. I'm not going to go over. That's pretty straightforward to read, and a review of the OSI model, but we just covered that in pretty good depth in the Network Foundations class the last couple of weeks. So once again, I'm not going to bother to go into too much detail on that one today, but I will emphasize that it's important, if you didn't quite get it down in Network Foundations or don't have it from your previous experience, then you want to make sure you review it again and look over it, because it's a very important model for how we look at networking. And because also you're going to see throughout this course, actually, and in other courses as well, and it was referenced, of course, last class, it comes back again. It's one of those things that is definitely something that shows up on, say, certification exams. It shows up on some of the quizzes and things within our program, of course. But it's also just a hugely used model out in the field. So you'll be looking at, maybe our system administrator might be looking at a piece of equipment, and the write-up literally will mention, this operates at this, might mention what layer of the OSI model or layers at the OSI model that it works at. So it's important to understand it, because obviously we need to make sure that we've done the right things at pretty much all the layers, right? To make sure that we're defending, and we're over this course, over the entire program, you're going to learn different ways to do those things. We'll learn about all kinds of different ways to secure the different layers of the model. The lesson 1 then ends with some best practices. It's one of the things that gets repeated, and it's in different contexts. you'll see some best practices in later courses. In many cases, some of the things that are best practices for security, best practices for system administration, best practices for securing certain devices, whatever the best practice list is, there will be some that will just get repeated over and over again. And I don't mean to bore you. We don't mean to bore you with that. It's to drive home the point. Like, it's amazing to me that still in this day and time that people out there break into systems, and it happens every day, all day, because people have not changed default passwords. They haven't applied the patches. So there's some of these things that are just, they're going to show up again and again in every best practice list, whether it's security best practices, system administration best practices, etc. Because we've got to drive these things home. If you leave our program and you go out and work for an employer and you set up a piece of equipment and you leave the default passwords, I'm going to be embarrassed. You're going to be embarrassed. Our school, everybody's. So we're going to pound this into your head so that you don't do those things, because they are the simple things that if you do right, you can eliminate a good 80% of the threats. A lot of the stuff, as we've already discussed, and we will discuss in much greater detail throughout the program, a lot of the attacks are automated. They're being driven by bots. And we're going to see this escalate as we see more and more machine learning and AI type of stuff applied in this field, both by defenders and by attackers. And so we're already, in a sense, you could argue we've kind of been there already. A lot of the things that are done are automatic. They're algorithmically based attacks. Or sometimes, so that, one machine, weakness will be found, default password, for example, and that's that attacker, the system, the software, the bot attacks another system, breaks in because of that default password, then, infects this device, and then that device turns around and starts scanning to look for more victims, building that botnet, building a bigger control. Now, what is that attacker going to use that for? Could be for sending out spam, could be for crypto mining, could be for denial of service attacks. That is just a common thing. I mean, and we're seeing it not just in the corporate world, where it still does happen surprisingly commonly. Less likely because people have, they're starting to get, sort of their heads out of the sand and be aware of the basics. But still, now with the Internet of Things, we're pushing technology more and more everywhere. We're pushing it into parts of a corporation or an organization that maybe IT and security aren't aware of. If somebody, if the break room microwave breaks in a company and somebody gets some petty cash and goes and buys a new one, but that's a smart microwave, we have now a potential attack vector within our organization that we need to secure, we need to be aware of. And if nobody told IT or security that this new smart microwave was brought in, and then somebody puts it on Wi-Fi, it could be a potential, a hole being opened, could be an attack vector. And then of course at homes, and that's where we're really seeing it. All these cameras and baby monitors and smart thermostats and smart microwaves and refrigerators and on and on and on. They are being bought. We're going to probably see, they're expecting within a few years to have billions of these devices. The numbers are just insane, and the estimates are from there on up as to how many. We'll probably see a lot of effectively IoT, Internet of Things devices as Christmas presents. So there's going to be a huge explosion of a whole bunch of new things. People will unwrap their gifts and get a new toy and plug it into their network and not change the password. And then within, probably before the new year, definitely into the new year, a lot of these new devices are going to have been taken over and compromised by attackers out there so that they can use them for their own nefarious means. So it's important to understand and be prepared to get some of these best practices kind of hammered into your head. As we move into lesson two is on cloud virtualization and various tools that we can use. There is a little bit of, and this is one thing that'll be kind of reworked as we go into the new year. There's some talk in this, and even one of the, though you don't have to do it in the 2-week model, one of the later assignments talks about GNS3. Obviously, you just had network foundations, you've set up GNS3 and done topology, so you get that. This goes a little deeper into sort of providing an overview of all these things for a couple reasons. One is that we need to be aware of these technologies. It is increasingly common. So many years ago, couple dozen years ago, everybody's systems were servers. You had physical hardware. Whether you had them on-prem on your own location, or you were hosting them somewhere at a data center somewhere in a cage in a rack. Companies and organizations would have servers, physical hardware, and that's what we were defending and what was being attacked. But of course, we have seen this explosion of other means of deploying things. And so we can deploy a web server, for example, not as a physical piece of hardware, but as a virtual machine. And when we are doing that, you did some of it. You made a virtual machine last class that was an Ubuntu server. That could have been a web server, a DNS server, anything. It's a VM. It's a real virtual computer. It does the full functionality. Within GNS3, we have these mini VMs. They have some limitations, but once again, they're virtual machines that allow us to do all kinds of neat things, in our case, to practice and to test and to learn. And so, but these aren't just toys that we use to play and learn, and they are important toys in that area. They are also really being used. If you think about lots of companies, and I've got some of it here, instead of having a separate server for every function, will instead deploy a large server with lots of RAM and lots of hard drive and some kind of virtualization like, well, obviously, we wouldn't generally in a corporate world use VirtualBox like we're using. That's a kind of, more of a, well, it's a type 2 hypervisor. It's running on your local machine, but we can run the bare metal types of hypervisors like vSphere from and Zen and others that we can install on a piece of hardware. And then there's a very thin layer of that software. That's the operating system, really. And then it just provisions and spins up VMs. And so why have companies done this? Well, the reason is that it's very efficient. If you have, for example, say a simple network, you've got a couple servers. If we can imagine just a hardware world, we have a couple servers. Just if a small organization, you should have 2 DNS servers. So you got one PC that's running, say, a Linux distribution and the bind DNS software, and then you have a second physical machine doing that same thing. But it's running the backup DNS2. So you got your DNS1, your DNS2, and then you have a third machine that is your web server. And each of those machines, now you have your primary and your secondary web server, DNS servers, you have your web server, and maybe a fourth machine is your email server. And that's a small organization's 4 physical pieces of equipment they have to run. And of course, DNS servers are only passing out IP addresses based on names and answering that question when a client needs that to get into a website or to send an email. The secondary DNS server, if the primary is up, is hardly ever being used. And so you can see that we potentially have a couple machines here that are not being utilized very often. And maybe the same thing, even our web server, if we're a business-to-business organization, business-to-business service model, then during the day when other businesses are on, they may be hitting our website, looking up, buying our products, doing whatever. But at night, it's probably not too busy. Now, the email may get traffic all throughout the day and night as, things come in, spam and automatic emails and, things like notifications from different, providers or vendors or partners. So, but here you have a situation where you're running 4 physical pieces of hardware and they're not really running the most efficient because, ideally you wouldn't say you got a 4 gig machine and you're only using a gig of RAM. The processor is very not the web server sits there all night with hardly any hits on it. Then that's an inefficient use of hardware. And instead, what an organization might do is buy one big beefy box with lots of RAM and a bunch of hard drive space, put a virtualization product on it, and spin up 4 different virtual machines. Now, to the outside world, there's still 4 different, there's a primary DNS, a secondary DNS, a web, and a mail server, but they're really running on one piece of physical hardware. And now that physical hardware can be we can more efficiently use that RAM. If there's a big load on the mail server, because of some, a bunch of traffic coming in, a big campaign, we're sending out a mail blast or something, then instead of, taxing that box if it was standalone, well, if some of these other virtual machines aren't needing as much of their resources, then the underlying system can be set up to give more to that mail server so it's responsive. And so that was sort of the first step of virtualization in the organizational world, was to bring it in-house, or once again, apply it at the data center. Instead of having a dozen machines or a whole bunch of racks and blades and servers in a rack, we now have a handful, really powerful ones, but they're running multiple web servers, multiple servers. And then of course, the big boys, if you will, Google, Amazon, Microsoft, etc., have, for their own reasons, built these cloud services. Well, what is cloud service? It's actually nothing but virtualization on their servers. They have built huge data centers, and they, instead of you having to now buy one beefy box to manage and run your own VMs, you can go up to Amazon Web Services, Microsoft Azure, Google Cloud, and you can spin up full virtual machines. So you can spin up, and of course there's other models of that as we're going to learn as we get deeper in. but you can even spin up a container, sort of like the Docker appliances, the mini VMs that are inside of GNS3. And that might only contain the stuff to run a web. It's not a full VM, it's just a service. And it can run that website or power a database or run your email server. So virtualization is hugely important to know because it is the model we operate in now. And, 20 years ago, you would have had, like I said, stuff on premises that you had to deal with or maybe hosted somewhere. Now we still have that, especially in big organizations. Big organizations have their own data centers, they're hosting at other data centers, and we're in this hybrid model where they've begun to move large amounts of stuff to the cloud. And so they've spun up VMs and processes and containers up in the cloud. And so now a corporation, organization has on-premises, hosted, and cloud services that their organization depends on. Maybe there's still internal servers to run accounting and project management that aren't in the cloud. Then there's certain things that are kind of a mix of some on-prem, some off. Many corporations, for example, might still be running a DNS server in-house, but because if that connection goes down, then nobody can get to anything because the DNS is not reachable. They may also have spun up a third or fourth DNS server in the cloud so that if their main connection is down, and of course, that's also what virtualization and cloud can do for you. We can easily spin up more copies. In the cloud model, we can place them all over the world because Google and Microsoft have data centers all over the world. And so, if you're a smaller company, you may spin up one VM, just like you might have one virtual, one machine to be your one server to be your web server. But as you grow and get big, you don't want all that traffic coming back to one place. You want a faster response time to your European customers or your Asian customers, if that's your global market. So you would spin up multiple. Think about what happens with Google. There is not one Google web server. It's not the way it works. I mean, you can do this experiment at home. Do a trace route or trace RT if you're on Windows, or if you're on Mac or Linux, trace route spelled out, and then space google.com, and watch the hops from your house through your provider out to wherever you're going, and then you'll get an answer from somewhere. I live in Austin, Texas. When I trace route to Google, it goes to Dallas. If I'm out of town, someplace in other parts of the country, and trace route to Google, it'll go to other data centers. So in other words, Google has Google all over the world in different data centers, and whoever you're closest to, you will get that hit. You get that fast response. And that's what you want to do if you are a large organization. You're going to want to have servers around the world. And so we have this hybrid model of, companies having stuff in-house, companies having their own data centers, or still hosting things at private data centers, and now moving large quantities of applications and processes into the cloud, which is really just a virtualization on other people's platforms. The advantage, especially to like a startup, is that a startup doesn't have to invest in all the equipment. They can spin up some VMs, launch their web application, launch their game, and see if it works. And if they need more, they can spin up more and pay incrementally, and they didn't have to invest in a whole lot of hardware and software. They can sort of pay as they go, right? Now, the other part of why cloud and virtualization is so important, though, does tie back to like why you're in this program. You're here to learn. And one of the ways we can learn, especially in cybersecurity, is to play. We have to get hands-on with this stuff. And as you've already seen by building a few topologies, and you're going to see in the next class after we kind of get this first tier done in this overview of system administration, we're going to start diving into a lot more classes. You're going to get whole topologies to play with, virtual machine, virtual appliances in there, machines you can attack from, machines that are vulnerable, scanning to, and you're going to have all of this, a little mini network that you're going to be given in the next class. And so I want you to be familiar with all this, because this is how we can learn. If we need to play, we can't just go out and randomly attack somebody to try to learn how to attack or to learn how that works so we can defend it. We have to be able to do it in a safe place. We can't do it even when we get to work, in our corporate environment without, some constraints. We can't just pound on the web server during the prime business time. That's going to probably piss off management that the web server is slowing down and customers are mad. So we have to balance those types of things. But we can do a lot of testing, a lot of learning using virtual machines and virtual technologies. There's a couple things that I want to point out about this lesson before I move on. One, and I'm going to, let me pull this up real fast, because I will do one little quick screen share here. There is a lesson that is, I believe everybody has to do, and that is to play with something called Packet Tracer. And basically, what you need to do, and I'll go ahead and let me share my screen. You can follow the instructions. I believe there's a link. I've just done a search on, let's do it this way. I've done a search on Packet Tracer, takes me over to Cisco's Network Academy. And what the course wants you to do and the assignment wants you to do is to create an account here, which is free. And you can take this Cisco Packet Tracer course. As part of the course, you'll get the download instructions for, you know, how to, like here, down here, how to download Packet Tracer. Now, what is Packet Tracer? Well, Packet Tracer is, in a way, kind of like GNS3. Okay, GNS3 lets us simulate networks. Packet Tracer lets us simulate networks. It's actually true. It's funny, I mentioned it in the Network Foundations class, but GNS3 stands for Graphic Network Simulator, but in many ways, it's not a simulator, it's an emulator. It's really running VMs and micro VMs and Docker appliances in there, and they all work just like a full VM does. And so you can ping things and set things up and it all works, but it's actually, each one of those is running inside of Oracle VirtualBox, right? Inside of that GNS3 VM. So it's VMs inside of VMs, but we're running many versions of real systems. Cisco Packet Tracer actually is a true simulator. It is a program that has been written to simulate, and it works very much like GNS3. You get a tool panel, you can bring in various and sundry devices. One of the things that's cool in some of the most recent versions, I actually just recently added it, you can actually get Cisco Packet Tracer for like IBM, it's old school, for like Android or Apple, like iOS devices. I put it on my iPad 2 Air not too long ago, and I had a lot of fun playing with it. In the case of the lesson, you'll just need to download it to your system and install it. And when you run it, it is self-contained. It doesn't fire up VirtualBox. It doesn't have a VM because it's not a virtualization. It's actually a simulation. Somebody coded all of this. They wrote all of this. You can imagine, we'll talk more about programming later, when we talk about shell scripting and then the Python class later. But if you can imagine a series of if-then statements, if somebody types in, you know, this thing, then it happens. And so they've written this Packet Tracer program to simulate the ability to drag routers and switches. And so at the high level, it works just like GNS3. The big differences are twofold. One, GNS3 is real emulation. We're running virtual machines and virtual containers, whereas Packet Tracer is a simulation. It's simulated. Works very similar. You can still make things work. You can configure the routers. You can ping from one device to another, but that's all being simulated in software. If this, do that, not because it's really running many versions of those devices. It's running simulations of those devices. Now, the other big difference is GNS3 is vendor neutral. Open source stuff is supported. We only use open source stuff. If you go work for a company that actually has Cisco appliances, then through their licensing, you could get the real Cisco virtual machines to run inside of GNS3. Or if you work for a company that uses Juniper, you can use the licensing there to run a real Juniper router inside of GNS3. In Packet Tracer, you're running a simulation. But they created this, and it's actually a very cool tool, and almost everybody should be aware of it, because even if you don't go to work for a Cisco, you know, you might decide you want to learn some. You might want to get some of their certs at some point. I'm looking into some of those myself with some classes I plan to take next year, just to continue to add to my own background and skill base. But nonetheless, that's, you know, it's a great tool because you'll see it in a lot of classes, not just Cisco classes, but they built it to back the Network Academy. So there's this free course you can take to learn how to use it. And you'll see that it's kind of at the surface level, it works very much like GNS3. But if you really picked some very weird, esoteric, hardly ever used Cisco command on a router, and you issued that at the command line of one of these simulated routers in Packet Tracer, you'll get an error and it won't run. Whereas on a real router, it would. And in GNS3, it would, because it's a real emulation. It's running the full software as opposed to the simulation. So if they haven't programmed it with an if they type this command, do this type of thing, then it's not going to work. But it actually is very powerful. It's good to know. And of course, you know already about GNS3. So that sort of stretch goal is not, you've already done it. One of the reasons that's in there is because when we first started way back last year or early this year with this program, the system admin class was actually the second course in the program for a couple of reasons, and now it's the third course in the program. And so that is sort of a little bit of redundancy there, but I wanted to expose people to GNS3 a little bit even when it was the second course. And then the third exercise is actually about cloud. You're not required to do it, but it's a great stretch goal. And all of these providers provide a free cloud, account. Now you do have to have a credit card to set those up. You don't have to have anything for Cisco Packet Tracer. It's a free, just set up, use your email, set up an account. You get in there, take the course. It takes a handful of hours, up to maybe 10 tops, depending on how much time, how fast or slow of a reader you are, how much you play around with the tool. But good to know, it's another tool to learn. And if you go to work in a Cisco environment, then it's a great way to learn Cisco stuff or to emulate. You can build your own network, simulate it. Of course, it's like I said, you can use GNS3 too, and use real emulations. You can use your licensing from your company to download the actual images of, say, a Cisco router or firewall, and basically install those in GNS3, and you'll be running a full virtual version of that inside of GNS3 as opposed to the simulation. Now, you're not going to find GNS3 probably for a long time running on, say, like an iPad. So you can tell that's the difference, because we'd have to have VirtualBox, a VM, and GNS3 to get all that running, whereas it's just a program. It's just a standalone program. So they've taken that code. It runs on Windows. It runs on this. It runs on Android. It runs on iPad, etc., iOS. So the minimum, you got to do the packet tracer exercise, and you should be aware of it. There is a free cloud provider. That's an educational one. It only gives you a couple VMs to spin up, but it's totally free, and they don't actually ask for a credit card. So if you don't want to put that in, you can use that. That's in the lesson. So then going on to lesson 3, network components. This is kind of an overview, and I know that a student has some experience, so I'm going to skim these and let you ask me questions if some of these are new to you. But basically, it's a sort of an overview. Make sure that, especially, we have a different backgrounds of some of the people coming in, depending upon what their background is. Windows support to networking to whatever different certs they may have to qualify to get in our program. So we want to kind of level set everybody here. What are some of the common components that are part of network components? Well, routers and switches are kind of the big backbones of most of what we do to connect. We might have a whole office connected to a switch, and then that switch connected to a router, and more offices, other floors of the building connected into different routers and the different switches, so that we can isolate different segments, keep accounting over here separate from the engineering group, but yet through the routing they can all get out and get to the internet and surf the web and do what they need to do their job. Access our cloud resources. Maybe we're using Office 360 in the cloud at our company, right? So we have to have that basic networking. Those are pretty standard pieces of equipment. We're going to spend more time on them. We already played with them in Network Foundations. We're going to learn how to secure, attack, and do different things to them later. But those are sort of the really common components. And then what are some of the other components? Well, you might have login types of identity types of mechanisms, and we'll talk more about those in the access management class later. You would have potentially web filters and proxies, and all of these are just kind of high level in this lesson. We'll come back to them as appropriate. All kinds of different filters. One of my favorite filters that almost every company should have, if they're not using, say, Google Mail or Office 360 and they do it for you, is some kind of spam filtering. I mean, if you just throw a mail server for a company up on the internet, it's going to get flooded. There's estimates that 80% of all the email SMTP traffic is spam. And there was a time years and years ago when we went from a simple day. Email's been around. It was one of the early things, one of the first killer apps of the internet, when it goes back to pre it ever being something most people knew about, before the web. Going back into the 80s, 70s, 60s, the email was a big thing. It's been around forever, and lots of people just threw up servers, and it was all an open kind of environment. But then, of course, at some point, obviously, as it finally reached a critical mass and various people, hackers and criminals figured out, hey, I can use their mail server to spam out all this mail. So everybody's had to lock down their mail servers, so we're not open relays. But even then they take over people's machines and have them send the email for us, take over servers and use them. So all of this mail is going out, all this spam, whether it's Viagra ads or, whatever the thing is. All kinds of things. And of course, now we're seeing, more recently, a huge explosion in both phishing and spear phishing, which we'll talk a great deal more about. You'll even learn how to do later in the program. And so we need to have some kind of filtering, right? So spam filtering is hugely important. If you're running your own Linux servers, there's a program called Spam Assassin, which is basically a spam filter and you can set it up to use different blacklists of known spammers, and you can drop all that traffic, and then your users get a whole lot less junk, right? Some's going to get through. It's just like anything else. They're always changing the wording slightly or trying to embed their message in a graphic, make it look more and more real, try to avoid getting caught by the spam filters. So it's kind of this cat or mouse game, but we definitely need them. Many companies use proxy servers or web filters to filter what their employees can do. Some companies don't allow employees to go to Facebook and stuff like that while they're at work. So those are being blocked either at the firewall or through some kind of proxy or filter. And then of course there are security related components that we're going to have to manage and maintain in a system. So these include things like IDS, which is intrusion detection systems. Intrusion, and you're going to play in a couple classes a lot with one called Snort, which is an open source IDS/IPS. And the IPS is just intrusion prevention systems. In many cases, the products are the same, whether they be software or hardware products. An intrusion detection system does what its name implies. It detects something is up. It sees, oh, certain types of activity. It looks like that might be somebody trying to attack our web server, somebody trying to do whatever, somebody trying to pass in a misconfigured package, somebody trying to pass in SQL, for SQL injection, as you'll learn also about later in the program. And so it'll just detect it and alert. Intrusion prevention is the same, but it actually takes action. So what you usually see is, and we'll talk a lot about this in the logging and monitoring course, and you'll play with the different, some of the different ways that this can be done. But generally speaking, intrusion detection is sort of set off to the side. It's just monitoring all the traffic, maybe capturing all the packets through a couple different mechanisms we'll talk about. And then it sees anything abnormal, sort of like your antivirus thinks it sees a virus, it'll pop, try to take action. That is more preventing trying to. That's more like, so intrusion detection just throws an alert, sends an email, does whatever. But then if you want to put something, you want to put that piece of that equipment in line, then what you can do is, instead of just saying, hey, something seems up, throw an email to the administrator, we can actually take action. That intrusion prevention can say, drop those packets, block that IP that we think that attack's coming in from. So they're really kind of two sides of the same coin, and we'll spend a lot more time playing with them. And then there are a number of other acronyms. We have a lot in tech, right? We have a lot in security, and we're going to talk about these again in logging and monitoring. But there's something called SIEM. That means Security Incident and Event Management. So these are systems, and so there's others as well, UTM, which is Unified Threat Management, or even NGFW, which is Next Generation Firewalls. These and some other things we're going to talk about, including NSM, which is Network Security Monitoring, there's some subtle differences. We'll talk about them in detail in logging and monitoring. But really what it comes down to, whatever their marketing name or whatever category they supposedly fall into, the idea is that instead of just having all these isolated defenses, we now have this system in place, a security incident and event management system. And what it does is you feed it data from, or any of these pretty much, you feed them data from logs of various servers, firewalls, intrusion detection, etc. And it all comes into kind of one central place. You might have a web-based dashboard to monitor it. And then when something happens, once again, alerts go off. But now all that data has been, instead of somebody having to run out and go check the logs on a bunch of individual machines, it's all been centralized. So you can click and board down, see what's going on, decide if you need to take action, if it's a fault, is it real, is it a false positive? And so there are various types of security related tools. Obviously firewalls fall into that as well. These are all the different components that system administrators, generally speaking, are responsible for installing and then maintaining, as we talked about in lesson 1. And they are going to work with security because obviously, they may install that piece of equipment for us, but we're going to make sure they follow the policies and procedures and the guidelines that have been developed, so that they're implementing the firewall rules that we've decided need to be in place for our organization, that we're filtering the traffic in or out as we need to based on our goals and our security goals. Lesson 4, as we move on, like I said, then there's once again some best practices to wrap up lessons. Some of these will be redundant, that you're going to keep getting pounded. Don't leave default passwords, but there's different ones in some cases that apply, more particularly to a particular component, whereas some of them are more generally applicable. Then lesson 4 is an interesting lesson because it's one of these things that most people we've found, at least in the program, there are a few exceptions, and Herschel, our current user, may be one of them. But usually people have had some experience, or at least aware of other operating systems, but they may not understand the big scope. And in this day and age, it's really important, both as system administrators and as security professionals, to understand the big families. And there really are, when you really get down to it, there are three, is the way most people will break it up. You could argue that there really are only two families anymore, but the way we've broken it up in the lesson is that there are three. So the first is sort of the Microsoft Windows family of operating systems. Well, what do you mean by the family of I got Windows on my computer? Well, it's not a family. Well, the thing is, there is, because there's, even though it's not in support anymore, a recent study, operating system study, showed that today, just recently, still in this year, 4 to 5% of the computers in the world are still running Windows XP, and it has been end of life. It doesn't have any active support anymore, but still. Now, a good chunk of those are embedded systems. Most of the ATMs in the world, if you were to open them up, there's a computer in there running Windows XP. That's just a known thing, and that company's paying a lot of money to Microsoft to still get updates. But that kind of stuff is one example. But a lot of places, maybe there's applications that, because they never got updated, they can't run on the newer OSs, or maybe it's, more developing parts of the world and they still have only the older equipment, so they're still running an older OS. But 4 to 5% of all computers in the world are running Windows XP. And then there's a chunk running 7, still, big chunk. Windows 8 and 10 are, of course, the more recent versions of the desktop operating system. But then there's a whole family of server operating systems. We can go back to Windows NT, to Windows, and they started naming their Windows Server based on different, like Windows 2003, Windows 2008, 2012, now 2019 was re-released back in November. So the Windows family of operating systems, and there was for a brief time, though that's been abandoned, a Windows Phone. They tried to get into the phone space, and my wife, there's one in the closet, sort of keep it in my technical museum of older devices. I don't like to throw things away. Sometimes they come back up, or I get to use them in class or something. So I have a Windows Phone. My wife had it for a brief time, hated it, and we moved away from it, even though we use Windows quite often. I'm actually fairly agnostic when it comes to operating systems. I love them all. I use them all. And so we're going to try to get you there. Then the next family is Apple. Apple devices, Apple Macintosh computers run something called Mac OS. Used to be OS X, used to just be Mac operating. It's had a different series of names as they rebranded. They used to number it, then they start calling it by things like High Sierra. It used to be named after cats. There was Panther and Puma and all these different names. And then, of course, there is the other side of it, which is the iOS side, or really there's a whole series. There's the iWatch operating system for the Apple Watches. There's iOS, which drives iPhones and iPads. There's tvOS, which drives their Apple TV products. But they're all based on a common underlying platform, and they're moving closer and closer together. And the one thing that really makes it unique is Apple likes to control their whole ecosystem. As a matter of fact, technically, it is not legal to, on a Windows machine, run a Macintosh VM, an Apple Mac OS, OS X virtual machine. Why? Because according to the licensing agreement from Apple, their operating system only can run on their hardware. Technically, it can be done, and there are numerous workarounds, but not necessarily needed. I have a couple Macs in this house. I have lots of Linux servers, and I have lots of Windows boxes. So, but it is one of those things that's technically because they control their ecosystem. So there is that whole Apple family. Now, then the last family is what we call the Asterisk NIX, which is basically the asterisk is the wild card there, right? Of either Unix or LINX, Linux. The Unix Linux world is the third operating system family. This includes and there still are Unix flavors out there. Solaris and technically SEO, IBM's got one, and different flavors. But Unix, its history was a proprietary operating system from various companies, and it was generally pretty expensive to license. And so what happened is a gentleman named Linus created Linux, and as an open source clone of basically the Unix platform. It's a very powerful operating system, either flavor of it. And at the end of the day, Linux, of course, is really just taken off because instead of having to pay thousands or tens of thousands to license somebody's Linux, Unix installation, you could use for free a Linux distribution. And now there are, just countless Linux distributions. Some of the biggest ones like Ubuntu, CentOS, et cetera, that you might have used and will use in this program. And there are others. The funny part is that actually there is one other one that you may not be aware of is in that family, and that's Android. Android, the operating system for mobile phones, and technically the largest installed operating system on the planet, because there are more Android mobile devices than all of the Apple, iPhones and devices, all of regular computers or Apple computers, Windows computers. So while there are whatever number of those, there are a lot more Android devices. It's the largest installed base of it, which really means that Linux is the largest operating system family in the world because of Android. Now, Linux is also taken over in the cloud, and like we see with virtual machines, because it's free. So why pay Microsoft for their server version and have a bunch of GUI you may not need? They even have a core version that strips the GUI out themselves, because lots of times admins don't want that. They want to get down and get it efficient. Or we could pay a lot to somebody, that still has a Unix license, licensable product. But instead, everybody uses Linux pretty much. And there was a time, and I think it's pretty close to still accurate, where the quote would be that about 80% of the websites in the world are powered by Linux. They're running Linux. And they used to be Apache only, but now there's Ninjix as well, which are open source web servers that are actually kind of sisters and brothers and sisters in a way. They spun off of the same source code base. But nonetheless, the Linux world and the Unix world is the Unix part small because it's still proprietary and somebody has to pay. The Linux world is huge, and then Google took Linux and used it as the base to build Android. And so while you're looking at your Android phone, actually you can get from the Google Play Store a terminal, a command line, and you can open up and you can be at a prompt on your phone. And of course, do certain things like type an ls command and see what's in that folder. Use the change direct, cd command. All the stuff you learned in Network Foundations will work on I have them on almost every one of my phones, especially if I end up rooting them, because then you have full root access. But you can still do some useful things at the command prompt on an Android phone or tablet. And so now the one thing I just do when I can't help myself but add it, but like I said, there's the three big families: the Windows family, the Apple family, and the Unix or Nix family, the Unix Linux family. But the reality is, if you really dig down underneath Mac, iOS or Mac OS, it's a Unix kernel. And so if you open up a command prompt or a terminal on your Mac, if you happen to be a Mac user, you're going to be able to do the exact same commands, ls, cd, et cetera, because under the hood, Apple is really Unix. And now that changed. And back in the old days, say the Mac OS 9 and back, early stuff, going way back, they had their own proprietary operating systems. But when Steve Jobs was brought back to Apple, he had gone off and formed another company. In the meantime, after originally founding Apple, then being sort of kicked out by the board, he went off and formed Next Computers, and he built another OS that was based on the AT&T Mach kernel. In other words, a Unix kernel underneath it. And when he came back to Apple, that was one of the first things. He's like, we got to get rid of this old crappy OS. We got to build a new one. And of course, they put their GUI, their look and feel. If you were a Mac user, it was, it's changed over time, but you would feel comfortable the way it worked. It's kind of similar, whether it was the old standalone version or the new, more modern Mac OS versions. But under the hood, it's really Unix. So the reality is, we really could say there's two families. There's the Windows family, and all of the Unix-based or Unix-derived OSs are of the others. But nonetheless, because of the proprietariness of the way Apple does things and the way that they tie their hardware and software together so that I can't just run a Mac, technically it would be kind of cool. I mean, technically, if you look at an Apple like an iMac computer, I have, like I said, a couple. They have Intel chips inside. They have RAM, they have hard drives, they have NVIDIA video cards or whatever is in there, different video cards. They're just a computer like your Windows computer. The only difference is that they're running their OS. So technically, there should be no reason you couldn't run the Mac OS just on what used to be a Windows box. Just like almost any Windows computer, if you got an old Windows box at home and you have no use for it anymore, it's an old XP box, for example, and you have nothing, make sure your data's backed up off of it, burn yourself a CD of that Ubuntu and install it. You can have a hardware Linux machine. And Linux actually runs usually a bunch of old hardware much more efficiently than the sort of, higher overhead of Windows and Mac, especially if you just stick to a command line server install. But nonetheless, like I said, that's what really makes Apple unique, is their licensing and technical tie together of the hardware and software. At the end of the day, it really is, though, a Unix-based operating system. So you could say there's really only two families. Now, the last thing that I want to talk about is, and I'm going to split it a little bit because of my time constraints here today, and because actually when we get into next week, we have some more overview stuff. So I will get into a little bit of overlap here. I'm going to talk high level about this, and then I'm going to do a little bit of demo next week before we move on to the next topics. But lesson 5 is on shell scripting. And if you've never done any programming, this is going to be your first experience to programming. That's why I'm kind of going to split this. Talk a little bit about it high level, and then we'll do some quick demos next week before we're moving on to the remaining lessons. What is shell scripting? Well, the reality is scripting, shell scripting, or any type of scripting is really just programming. So I'm not trying to scare you, but yes, you're going to get your first exposure to programming in this lesson. Now, why is this here and why is it important? Well, because to be honest, there's 2 reasons why. It's in system administration because system administrators do this stuff all the time. Instead of, if you have a case of where you need to sit down, say once a month, and run a dozen commands on a Windows PC server or a Linux, or technically even a Mac, right? Because it's underneath, it's Unix. You could just sit down, open up the prompt, type your commands in, and do that every month. But if that takes, say, 30 minutes to issue all those commands and do that, so every month for the rest of the time you're at this company, you know that at the end of the month, you got to run these dozen commands. You're doing some backups, some archiving, some zipping, copying some stuff over to whatever. And you just have to do this every month. Well, if you took a little time, 1 month, and sat down and wrote a script, which can be as simple as just a bunch of commands that you could have typed at the prompt yourself, all into one file. And then you do that, and you test it and make sure it all works. Then you may take you an hour instead of half an hour because you now got to test it and make sure it works. But now you have this script written, this little file, this little text file basically, and it just has those dozen commands you run. Now maybe it's got a little bit more logic in there, and we'll talk about that in the lesson. But I'm just keeping it kind of high level at the moment, because at the very, very, very basic level, a script is nothing more than a series of commands you could have typed at the prompt, but you put them into a text file with the appropriate, naming and conventions, .ps1 if it's a PowerShell script, usually .sh on Linux or Mac if it's a shell script. And you set the permissions right, you set your properties right of your different environment, because there are 2 different environments we're going to cover. You only really have to do one yourself, but it's good to know both, and I'll get to that in a second. But so you create that little file. Now you've taken the time to not only type those commands out, but maybe have some logic in there, maybe some wait so it can finish one before going on to the next, whatever. And now you've done that. So then every month from now on, you're going to sit down and go, oh, it's the end of the month. Run end of month script and go to lunch and let it do its thing. And that's how shell scripting huge. I always use this example, and especially folks who have Windows experience. Let's say you worked on a Windows server before, and so you get a new user. And so you can go into click the file menu, go into the admin tools, you can go to user and account management tool, and Active Directory, users and groups, create a new user, drag them into whatever group, give them their permissions. It's easy, drag and drop, point and click. But if I came to you and said, okay, Mr. System Admin, Miss System Admin, I don't just have one new user to add for you. We bought a company with 10,000 users, and we're going to merge them all in, and you got to add all those users. Are you going to want to sit there and go file new user, click new user, fill in? No, you're not, because you'll take forever to enter those 10,000 users, and there's so many chances for mistakes. Instead, there are command line ways to do this, whether it's on Unix or whether it's on Windows. You can use PowerShell. And so we can script that. And as a matter of fact, we can script it in such a way that we might just have a create new user line that's inside of some kind of loop construct within programming. And then we might have it read from an external file, which might be the export of all the users from their system that we can now read. And so that we can run this script and it's just going to go read the next user and create them, read the next user, create them. So these types of being able to write scripts to automate stuff is hugely important to system admin. It really speeds things up, and you can automate a lot of things. Now you're going to find in security, this is why we're teaching it. Even though this is a system admin overview, we're diving a little in a whole lesson here on shell scripting, because of the reason it's important to system admin. But we could have just overviewed it and walked away. But we want you to learn a little bit of programming. We're going to teach you a programming course later, because as security people, we use these scripts too. What if you need to do a whole series of scans? You need to scan this segment and this segment, and you're going to do this every week to make sure there's no rogue devices on your network. Well, you could sit down as you're going to learn how to type in maybe some nmap commands or something in the later classes, and you could run all these scans. And once again, you sit down at the command line, type your command, sit back, wait for a scan, run another one, run another IP range. But you could write a script to automate that. So every month you say end of month scans, and you run that script and let it go off, and it could output everything to a text file for you. You can get them as complex as you want to, or it could just be as simple as time saving. And so this is why it's important to security people. And actually, when you go a little beyond our program, as I've mentioned in different workshops and in the webinars we do to support them, our program is fully aligned with CompTIA Security Plus. But the reality is we cover a bigger chunk of their cert pathway. We cover a good chunk of networking, obviously. We cover some Linux, obviously. We cover the pen testing and SCI, which are the next exams up in their track. About half of all this. So we cover not only all of Security Plus, big chunks of other of their certs. And in the Pen Test Plus certification, which is the red team, attack side certification beyond Security Plus, you actually have to know scripting, at least at a high level, in 4 languages: Bash, PowerShell, Python, and Ruby. In our program, we cover in this lesson Bash and PowerShell, which are the simple scripting languages and well-used, commonly used, powerful languages behind Unix, Linux machines. Generally is Bash scripting. That stands for the born again shell, and you'll see how that's done. And the lesson takes you through how to write simple script in both languages. You can decide for the exercise which one you want to repeat and do it in and go further and take it and follow the instructions. But I highly encourage you to play along with both. Now, you may say, I only have a Windows machine. How am I going to do? Well, you built that in Ubuntu VM. That's a Linux machine that has a Bash. So you can fire that bad boy back up, get to the command prompt and do all your Bash scripting there. And then you can just open up your PowerShell terminal. And there is a note. There are 2 notes that are important, because I don't want anybody to get stuck when you start playing with this before I demo next week. One is, if you're doing Mac or Linux Bash scripting, you can create the text file, put all the commands in there, name it .sh, and then try to run it, and it goes, doesn't work. Why? Well, remember we talked about permissions in network foundations. Those groups of read, write, execute, read, write, execute, read, write, execute. Well, you have to make sure a script has been changed, and the lesson covers how to do this, so that you have we also covered the chmod command in Network Foundation, so you're going to use it again. You create that script, you have to chmod it, change its mode, so it's 755 at least. That's, you get everything, the read, write, execute, but then the group and the others get read and execute. It has to be executable or it won't run. Now, there's a different little caveat when you're doing Windows PowerShell scripting. On a standard Windows 7, Windows 10 machine, by default, even though there's a PowerShell script language there, if you write a script and create it on your own machine and then try to run it, you're going to get this error, because by default, to avoid hackers using PowerShell scripts, which they do, and another reason why we need to know them, because they'll be used against us as well as we use them ourselves to automate things, is that most scripts have been disabled so that they do not run. And there are technically 2 ways to fix that problem. You can change that feature globally on your machine, but if you do, then you lose the protection of why that was turned on in the first place. So if somebody sends you a script and it somehow gets executed, you clicked on it, or it somehow else because of an exploit gets run, and that protection doesn't prevent it, then that script's going to run off in the background, do its stuff, download more crap, and now they've got you. On the other hand, what you can do, and what we advise from the lesson, is you can create a custom shortcut. And this is what I've done. I'll show it to you next week. I've done it on this machine, then on my other machines. I do it on every machine. And that way, when I want to open up PowerShell when I'm in a script, I will open that. I just copy another PowerShell icon shortcut and rename it PowerShell scripting. And then I go into the properties of it and I change the command line and pass in that parameter the lesson talks about. Space hyphen execution policy, whatever it is, I can't remember exactly now. But basically, you put that in place. Then when you launch that copy, when PowerShell comes up, that you can run scripts in that one. But if they're trying to run it in the background, they're trying to come through an email attachment or something else, they'll still be should be denied by the overall global policy. So permissions on bash scripts have to be set to execute. And on Windows, you have to give PowerShell permission to run scripts on Windows. Those are the two caveats. So when you work through the lesson, it's going to teach you how to, create both in PowerShell and in bash a simple script that does some copying of different files. And it shows you how to take input from a user and try to add more to it. And then your instructions and the assignment are to go beyond that. Okay, what else can I do to this? I'm going to make it, recreate it and then make it a little bit more. And we'll talk a little bit more about that next week before we're finishing up and getting into lessons 6 through 10. So that's all I have. I'm gone the whole time pretty much. That's the way I usually do with this block. It'll take a little while to download, process, upload, and get it put into the system. And then I have a one-on-one with this current student actually later tonight. So I'll see you then, and an office hour as well later this evening. So if you have, and of course in between, if you need me, just reach out on Slack or send me an email. Thanks. Have a good day.